Welcome to my demonstration of Pascal's principle. Oh, excuse the ruler on the right over there. Anyways, so first thing that we have to go over is that look at this green stick. It's going to be significantly lighter than the orange thing over here, right? Look at this. Or sorry, that's not supposed to happen. Look at this. So I can lift it up. Oh, sorry. I can lift it up just like so, and it's gonna move slowly, but point is, the amount of force that I'm moving it with my little, mouse thing, is enough to move the green stick. Now, that's important to remember, because if I tried moving the orange block with the same amount of force, the force here hasn't changed, it's still the same, that moved the green stick, it's not enough. The orange block is just significantly heavier than that. So, how does this relate to hydraulics? Well, let me show you this. Imagine we put this green stick and this orange block into a pipe, like so. This pipe has water in it, as you can see by the blue thing, and it also has some rulers. The green ruler is showing you how long 10 meters is in this pipe, and the blue and the orange rulers show how large 1 meter is in this side of the pipe. So that'll be more important later, but point is, we're going to pull this downwards, like so, and we're going to use the same amount of force that we moved to move the green stick. Now remember, the force that we're applying here can move the green stick freely, but it can't move the orange stick. But look at this. We're going to drop it lower. Some water is leaking out because the simulation isn't perfect, but anyways, that's besides the point. The water is going to move out of the way as we push downwards, again, with some force to move the green stick. And look what happens to the orange block on the right. It's moving from its original position. And its height has increased from about 1 meter, its height has moved 1 meter. So, point is, we somehow used magic to move the orange block even though it was heavier than the green block. And we used the same amount of force, so what changed? Well, if we duplicate this, I can show you a visual proof of how that happened. Duplicate it like this, and then move it like so, like that. There we go. And then we're going to delete this one, the piping, and then we're going to delete the sticks, or we don't need to delete the sticks yet. And look at the rulers, okay? We moved 1 meter of water on this side, so we're going to move that into the orange bucket here. And we moved all this water all the way down from, up top into this side. Now, if we start the simulation and we see how does it fall, what can you predict, right? You'll see if we speed it up a little bit. There we go. The water, if we can get this layer right here into it too, the volumes are approximately the same. So, what this is basically saying is that we moved a small amount of water through a large distance to move a large amount of water right here into a shorter distance. And large and small meaning colloquially, right? Because technically these are equal in volume, so they're not larger or smaller than one. But, as you can see here, look at how thin this is. It's in a very small area, or technically the same area again, but it's very thin. But we're moving it across a very large distance using a minimum amount of force to move this one higher. And so we traded it out for, long distance movement to short distance movement. And that's basically how hydraulics works. We're using liquids to move something through a short amount of distance, and that results in something heavier being moved across a larger amount of distance. There's other things related to how the areas are different, but for now, this is just an introductory video. You can tell that moving this with the same amount of force somehow multiplied it when, we moved this. the orange block. Because again, when we went back here, we're not able to move this freely. It's stuck. And yet, when we move this downwards, the orange block on the right moves. So, that's just to say that force multiplies when you're moving something like this because the areas are different, and that's related to Pascal's principle. But I should make another video because this is getting kind of long. So, I hope you enjoyed, and goodbye.